Right. Good evening once again from Nigeria. Thank you very much for joining the webinar tonight from whatever country you are joining us from. And the host is glad to have you on the call tonight. And once again, we do understand that there are participants joining us across Africa and beyond. Thank you. We'll be starting right away. And may I kindly request yeah, I don't know if it's a Mr. or a Miss Cosmas Olani to please give us the opening prayer. Kindly unmute and give us the opening prayer. Thank you very much.
Righteous Father, we bless your holy name. We thank you for making this gathering possible. We are asking you to give us everything required to assimilate, understand, and bring to the fore all that are necessary for our knowledge and for our development. In Jesus' name we have prayed. Hello?
Oh, I connection today.
Hello?
All right. Are you done? Before we continue tonight, we'll have the national anthem of Nigeria and also that speaker tonight is from South Africa. Well, a side gist is that our speaker tonight is from South Africa. I'll be taking national anthem of South Africa as well. We now have the national anthem of South Africa. We all enjoy that. Well, one of these days we'll get to play your home country whenever we have a presenter from different countries. So right straight into the business for tonight. We have a speaker already with us, and no other person than Kule Enyewale, currently a postdoctoral research in the Department of Mathematics and Technology Education at the University of Johannesburg, and lecturer at the Department of National University of Lesotho, Nigeria. He holds a PhD in electrical research, measurement, and evaluation in the field of testing and psychometric. Also, he has a certificate in program for everybody, getting started writing from the University of Michigan, USA. A certificate in the data science box and half programming language from Johns University, USA. His research interests include development and validation, psychometrics, variability, theory-based variability and analysis and evaluation, human methodology, functional modeling, and computerized adaptive testing. His current research involves advancing technological solutions for the purpose of developing for the purpose of developing a more effective and efficient method. Also, is an experienced and quantitative and qualitative analyst. And is a peer reviewer for several of the Association of Computer Advanced in Africa. Also, managing editor development research. In addition, he's a member of numerous learned society, including testing Africa and associate editor of the Africa Journal of Behavioral and Skill Development Research. In addition, he is a member of numerous learned societies, including the Association of Behavioral Research Analysts and Psychometric, American Research and evaluator of Nigeria among others. Please join me as but now, Dr. Kule Ayewale, you are welcome, sir.
Okay, there.
Good evening, ladies and gentlemen. I hope you can all hear me.
Hello, sir.
Can you hear me?
Good evening, sir.
Good
Yes.
evening.
Yes.
Good evening.
Yes, we can hear you.
Okay. Well, thank you very much for that presentation. Before I start my presentation tonight, let me first of all thank the organizer of this webinar and for considering me as the best speaker to speak in this section tonight. I really appreciate that. And I believe we are going to learn one or two things together tonight. So permit me to share my screen so I can start my presentation. I don't know if can you see my screen?
Yes, we
can.
Okay, that is very good. Thank you very much. Like the presenter said, I remain my humble self, Dr. Kule Ayewale, a postdoctoral candidate at the University of Johannesburg, South Africa, and also a lecturer at the National University of Lesotho. Tonight, I will be speaking on the practicability procedures to classical test theory and item response theory, psychometric properties of multiple choice items using R programming language for statistical computing. This particular topic is very appropriate at this point in time, where we, the educational assessment experts, psychometricians, we really need this at this point in time, because there has been a lot of, let me say, misconceptions here and there, especially about these two theories. This is one of the major theories we use in educational assessment. And I think the organizer of this webinar deemed it fit that members of this association need to be acquainted and keep abreast of the nitty-gritty of what these two theories are all about. And I understand that these particular theories, there has been some other speakers that spoke on the theoretical aspect of these two theories, so I won't delve much into the theoretical aspect of the theories. My function tonight is to put you through the practicability of how to establish the psychometric properties of multiple choice item using our programming language for the two measurement framework. In the course of my presentation, I have this work section outlined. I will talk briefly on the brief overview of R programming as a software, which is an open source software. And also I'll move to how to install the packages for statistical computing. From there, we'll talk about how to format your data to conform with the R environment, data importation into R environment, and the classical test theory and item response theory framework, the classical test theory measurement analysis, IRT, which is item response theory, or you call it modern measurement analysis. And after that, we'll look at some few hands-on activities on how to establish both the classical test theory and item response theory analysis. And if time permits us, I will show you how to interpret and report the outputs. I also understand that before this section, you must have gotten the software for both R and the R Studio. It is important that you download these two softwares and then you install it on your system. And after the installation, that is when you begin to enjoy the importance and the essentiality of this software and how multitask the software is. I will start my presentation by giving you a kind of a synopsis. For this, I use, here is a synopsis. Okay, I said, don't expect R to be like SACS, SPSS, which is statistical package for social sciences, Stata, and etc. We have so many softwares that you can use for analysis, but R is different from them. You can't compare R programming for statistical computing, you can't compare it with any of these softwares that I just mentioned. Here is a synopsis of a one-person story. And he used SACS. He was so conversant with the use of SACS, like many of us, that he really embraced SPSS because of its graphical user's interface and easy to use. But this particular person loves SACS a lot and is been a fan of an open source, attempted to learn R. He became frustrated with R and gave up. When he had a simple problem that he could not do or solve in SACS, he quickly solved it with R programming language. Then, over about a month, he became comfortable with R from the consistent study. Ladies and gentlemen, I want to tell you tonight that you can also be a wizard if you use this software constantly. And this is Patrick Bonds, UCLA statistical consultant. This is a statistical consultant, and his name is Patrick Bonds. And then, you know, like I said, he was conversant with the use of SACS before he shift his paradigm to the use of R, because how multitask and how important that particular software is in providing solution to some analytical problem that SAS cannot solve. Now, brief overview of R. What is R? I believe R is not a new thing to many of us. We might be hearing the word R software, R programming language, and essentiality, this particular software is mostly used by data scientists. they use R, they use Python. There's no way you talk of Python and people will not ask you that, what do you know about R? But they are synonymous in terms of function. The two of them, actually have the same function to me. I've used the two of them. So I can tell you categorically how the function. So what is R? R is a programming language that can be used to perform statistical and quantitative analysis. But I forgot to add this. It's not only a quantitative analysis. You can also use R to perform a qualitative analysis. Some of us, for qualitative analysis, we know of Atlas TI, we know of Mascuda, we know of InVivo, and so on and so forth. But let me tell you, most of these software that I mentioned, they are commercial in nature and they are very expensive to get. But you can also adopt R, which is an open source software for your qualitative analysis. And it's always a programming language because it makes use of code lines. You write syntax, you write codes to perform your analysis. It's not as straightforward as that of SPSS that you just point and click, or click and you just click and then you have your output. And there are so many things. I don't want to delve into the shortcomings that characterize the use of a statistical package for social science tonight. Is not part of my focus tonight. But if I talk about SPSS, believe me sincerely, you will not like to use SPSS because of its spurious estimation, where you use it to conduct or to carry out some data analysis. And since I realized that, I've stopped use this particular software called SPSS. And since I embrace R, all my analysis has been fantastic, and my client has been giving me kudos for doing so. The users of R, they are like wizards. Yes, they are like wizards because you have to think. There are so many code lines. Fine, I'm not a programmer. I'm not a computer scientist. I don't know how to write programming or do, but with dedication, commitment, and all that, you can learn R and you can find a solution on how to write some of these codes for your data analysis. In education, either social behavioral research or social sciences, we only need the applicability of this software. You are not interested in writing the program, you understand? We've seen in the course of my presentation, we have those that have worked in this area of R, and then they've done fantastic job in that direction. So the R use functions that have been established, and then we have some statistical researchers, although they can also create and develop their own. And that is another beauty of using this particular software. You can also build your own. And when you build your own syntax for a particular analysis, you can name it, you understand? You can name it your name, and then you integrate that particular package into the R environment, and it becomes something useful for other researchers for the analysis. The brief of R continue. What are the facts about R? It was developed in early 1996 by R. Aker and the R. Gentleman. These two researchers, they are from, I've forgotten the university in New Zealand, but the two of them, they are lecturer in the Department of Bioscience. And you can see they are scientists, you understand? And the two of them came up and developed this software. And since 1996, this software has gained many users and contributors, especially in the area of data science. And there is no way you talk of, we are in the fourth industrial revolution now, whereby we make use of artificial intelligence, we talk of Internet of Things, we talk of machine learning and all that. So there's no way you talk of machine learning and then you not talk of R programming, because you need something to drive the codes that you All right. Now, a widely used environment for statistical analysis, I've said that earlier, and the acronyms for it is R, and it is used within an interface, which is very, very important. And it's used within a command line interface. I told you it's used code lines, but don't, I want to allay your fear in terms of the code, because some people say, oh no, so do you expect me to start learning codes to do this and to do that? But I can tell you that it's something that you can learn, and then if you are committed and you want to start making use of this software for your analysis. What are the strengths and weaknesses of our programming language? One, it is free and open source. Like I told you rather, you know, in education, especially if you're a psychometrician and you're a data analyst, we have different softwares, and some of these softwares we use for analysis, they are commercial in nature. For example, if you talk of Excalibur is a commercial. If you talk of multi-log, it's a commercial. If you talk of Bilog, it's a commercial software. Many of these softwares that we use for analysis, especially item analysis, for calibration, equating, and so on and so forth, even M+. You know, so most of these software they are commercial in nature, and R has come to, you know, solve this problem of looking for one software, or, you know, this one is free, it's open source, you can download it, install it, and then you start using it, so while your system, you know, conform with the requirements. It has a strong user community. R has a community. There is a community of R, that is the users of this software. There is a community that if you have any problem, you can just post there that, oh, this is the problem I'm encounter, and then you will see someone that will come up and provide solution to that. And it's highly flexible. Why is it flexible? It is flexible because you can import codes from one line to another line. You can copy codes from one document and post it on R. It will take it. That's why it is so flexible. You understand? And another thing is the flexibility in terms of graphics and intelligence. Ladies and gentlemen, I bet it with you, and you are going to see the beauty of graphics that's embedded in this R software. You can't compare the graphics, you know, the visual that you are going to find on R compared to Excel or Power BI or other software that is designed for graphics. So R programming is a very good software that can give you this. And what are the weaknesses? You know, there is no way you talk of advantage and then you will not have no matter how good that thing is, it must have some limitations. And one of these is this slightly steeper learning curve than other software. That is, it's not as easy like other software that you put on the data set and then you click and then you have the result. So it requires a lot of time and all that. Then slow for large data sets. So when you have a pool of data set that is, let's say you have about 24,000 respondents, or you have 50,000 respondents. So if you use R for such analysis, then it will take a little time because of the algorithm, you know, because there is a lot of algorithm that's going to take place to make sure that the data and the analysis is well, okay. And another one is hard to learn. Yes, it's hard to learn, but with commitment, with dedication, I think it's something you can learn. If I can learn it and I was able to use it successfully, you can also learn it. And I believe it's something you can. Now, what are the commands in R? Actually, all these things I'm just giving you just for you to have a knowledge, a background knowledge about what the R is all about before we start using it for anything. I cannot just open my R and say, okay, we start using it for this and that without giving you a kind of background information that you need on this software. So if a command is not complete at the end of a line, then R will give you a different prompt than greater. So if you have a code line and that code line is correct and is complete, then you have a symbol like a greater down like this, something like greater like this. And by default, then you have this. So if the code is not completed and then you try to run it, it will be giving you this sign, plus, plus, plus. So once you see plus, what it's telling you is that no, this particular code line is not completed. So you have to do something or you end that code line in order to have this symbol back. Once you have this symbol back, it means that the environment is working perfectly. On second and subsequent lines and continue to read input or the command is syntactically complete. So that's what I just explained now. So when you have this, that's when you feel that, oh, okay, the code line is what is completed. Now, comments can be put almost everywhere with this hash. When you see this hash, it's not a code line. It's just to tell you that, okay, for example, if I want to, if I write code to import data, my data set into our environment, and I want people to know that, okay, this particular syntax or code lines that I'm using is meant to import data into the R environment. So I will just put this hash and I write in front of it data importation into R or data importation. So this sign, whenever you see this sign in any code lines, you know that it's not a real code line, but just to tell you that the syntax you are seeing, this is what the syntax is talking about. Yeah, we use vertical arrow keys on the keyboard, and this can be used to display the R command history. So if you have used some syntax before, probably 2, 3, 4 days ago, you've used a particular code lines for analysis, and then probably like a month after, or let's say a week or 2 weeks after, you still want to use that same code and you don't want to start racking your brain. You just press the arrow key on your keyboard and then it will bring that particular code lines that you use for that analysis, it will bring it back. And this is one of the advantages of using this software because it has memory to store whatever codes that you are using for your analysis. And okay, record process at the same time. So by so doing that, you save a lot of time. Instead of you started writing another code, you press the arrow key or down key, and then it will take you to previous codes that you've used. Still on R command. R command consists of either expression or assignment. So you must have an expression, and when you have an expression, then it is evaluated and then you print. It's like when you say A plus B. A plus B is an expression now or an assignment. So after saying A plus B, then what is the answer? So using this command, you can write an expression, you can assign an expression, at the same time print the result of that particular assignment or expression. Our commands are separated either by semicolon, or by a new line. So like you see here, I just gave an example of when you have xy equals to 2 plus 5. And I want to have another assignment. I say x2 equals to 4 plus 8. So when you see this one now, this is an assignment, 2 plus 5, this is an expression. You understand? You said x1 equals to 2 plus 5. Then you put column, semicolon, or you start a new line. So, and by the time you want to get the answer, you know that 2 plus 5 is 7. So this is an expression or assignment given, but you assign this to x1. So you need to print x1 to give you 7. as your answer. So if you don't print X1, there is no way you can get your answer. So when we get to the hands-on activities, you see the practicability of some of these things that I just mentioned now. Now, the language itself. Getting help with functions and features. So if you are stuck, and that's why I said the R is, to me, is something that you can learn on your own once you have the basics. If you are stuck and then you need help on something, for example, if I want to do, let's say I want to perform one-way ANOVA, now analysis of variance, and I don't know the code, I don't know the syntax that appropriate for me to use, you can just type help, then you open bracket and then just type ANOVA there, you understand, and press enter. It will bring out some clue about the syntax appropriate for that particular analysis you want to do. So for example, now if you want to, let's say you have an array of data and then you want to find mean, and you don't know the expression, I mean, the syntax that you can use to calculate or to compute the mean, then just type open bracket, close, and this, and then press enter. It will give you clue on the code of the syntax that you can use. If you don't want to write it like this, then you can also use this question mark, it's like help also. So, and then you write mean, so it will also give you the same thing. Also, another thing I want you to know is our statements, they are case sensitive. They are very, very sensitive. If you know that you are using capital, which is the uppercase, be consistent. If you are using the lowercase, also be consistent. So just make sure that if you use capital uppercase somewhere, and then by the time you continue with the code lines, you now write small, the lowercase, it will not run. So that's why I said these are different symbols and will revert to different what? Different variables. Now, how to install our packages. How to install packages. Next, we know we have R, but R cannot work on its own without having the package, the right package for that particular analysis that you want to perform. And that's why I give kudos to the developers of this software. After the development of the software, more than 10,000 packages were embedded in the software, more than 10,000 packages. So there is no analysis that you want to conduct, and this software cannot do it for you. Be it in science, be it in social sciences, be it in humanities, so it's all around, it's all encompassing. And that's why I like this software. I don't need to start racking my brain that, okay, I'm looking for a particular software, or except if the client says, oh, no, Dr. my supervisor, or this is the kind of software that requires that I need to report. Except that I prefer using this particular software for any analysis that I desire to run. So with R, you will have access to a wide variety of basic functions that are built into it. So they have some functions built into the program. And then as we are progressing, when we get to the hands-on activities, you appreciate the advantage and the benefits of this software in doing your analysis henceforth. R is a flexible platform designed to be able to easily extend it with new features whenever new ones become available. This is accomplished by using so-called packages. So this package also, they keep on improving on the embedded or the inbuilt packages. You understand? They worked on it, they upgrade it. So when there is new upgrade, there is a way I'm going to show you how to do that. If you have installed a package And probably in the next 2-3 weeks, there is need to upgrade in order to have other functions to be embedded in that particular package. Then you will see how to do that. During this section, I will demonstrate how to install different packages from different types of analysis. So a particular analysis has its own package. You can't use the same package for all the analysis. So each analysis has their own package that you are going to use. So the one we are going to do tonight also, I'm going to tell you the package you are going to use and how to install the package and how we are going to use the package for the so-called analysis. What is R package? An R package is an extension of R containing data sets and specific functions to solve specific questions, like I said. So each question has, or each analysis has its own what? Its own package for it. R comes with standard or base packages, which contain the basic functions and data set, as well as standard statistical and graphical functions that allow R to work. So there are so many functions that makes R to work properly. Excuse me. There are also thousands other R packages available for download and installation from comprehensive rural R archive network, that is CRAN. And there is another one, we call it GitHub repository. This GitHub is a place where people develop software. That's where they build software. Especially if you're a data scientist, you understand this particular repository called GitHub is a very powerful repository. And there is another one called Comprehensive R Archive Network, and the acronym is CRAN. So you have all the packages embedded inside the CRAN. So if you need any of this package, you go to CRAN and then you extract the one you need, and then you install it. And sorry, someone is writing on my screen. Daniel, please. Yeah, after installation, you must first load the package for using the functions in the package. So when you download and you install this package on your system, then you now call the package and then you start using it. And one thing I want you to know is when you download the package and you store it now, it is there forever. Anytime you want to use it, you just call. That's what you call. You just call the package and you start using it for the analysis that you want to conduct. So it's not that you start downloading and installing the same package anytime you want to use it. So you download it once and it is there forever, except if that system crashes. Install a package from CRAN. So the first one is the function install the package. That is the code lines that you are going to use to install a package from CRAN if you want to use code. But I'm going to teach you that is other way of doing this if you don't want to use the code. So we have the code, which is called the function install.packages, and then you have open close bracket. It's used to install a package from CRAN. And don't forget, this CRAN is the comprehensive archive network. This is where all the packages are. The syntax is as follows. So you have the install.packages, then you write the name of the package that you want to download, or you want to install rather. You write it, and that's why I put package_name. So you have the name of the package, and then once you press enter, it will start installing on your R environment. Please note, every time you install an R package, R may ask you to specify a CRAN mirror or server. Choose one that is close to your location, and R will connect to that server immediately. So many of us, we do choose UK, you will see UK, you will see Australia and all that. But I think the UK is very close to us in Africa. So I prefer choosing that particular location. Now, how do you import and prepare your data for the analysis? Each software has their way of preparation. You must prepare, you must format your data before you import it or before the software accepts your data format. The way a manner examines data points or inputs into R differs from all other statistical software, such as SPSS, MATLAB, M+, and so on and so forth. Now, the procedures now. So input examines data point into spreadsheet format, e.g. SPSS, then, or you have Excel. So you can have the data point, and I believe you all know what data point means. That is the examining responses to the instrument that you give. And then after that, you convert their responses into tab delimited or command delimited or space delimited. Those are the three file type extensions that they are accepted. So we have the tab delimited, and then we have command delimited, and we have the space. So either of these three can be used to format your data. All these format extension file can be directly read into our environment. Note, data point input on spreadsheet directly, such as SPSS and Excel, cannot be read into R successfully, unlike the converted file. So when you have SPSS, you have your data points, the responses on SPSS, probably you save it in SPSS or you just input it on Excel without converting it to either space delimited, tab delimited, or command delimited. And you want to use the one saved on SPSS or Excel straight away. You want to import it into our environment. Fine, R can take it, but you need package. You need some package that will do the transformation for you in order for our environment to accommodate or to accept this file extension. Now, this is an example. I have the responses on the, on the Excel sheet. That's the conversion of different spreadsheet data point to formatted file. So you can have CS, which is command delimited, we have tab delimited, and we have the space delimited. So these are the three file extensions that our environment accommodates. Importing data into R. How do you import data into our environment? Having done with all necessary conversion of data file from one file format to the other, importing formatted file into our environment is another crucial task. Now, to execute this, several steps involve. Create a folder. First, you have to create a folder on your desktop for the analysis. This will contain the formatted data or SPSS file or Excel file. So this is important. When you create a folder, it means that all the analysis you are conducting or you are performing will be saved inside that particular folder. And after that, you open your installed R software on your desktop page, verified working directory default, then you read the data file into our environment. These are the procedures that you need to follow to import data into our environment. Ladies and gentlemen, let me quickly talk a brief overview of classical test theory and item response theory. Like I said earlier, these are the two theories we use mostly in test in educational assessment. And for classical test theory, it's just looking at the reliability of the entire responses in terms of raw score. And as you know, that there is attached measurement error to this, where you have the observed score and we have the true score plus the error score. And it's because of this measurement error that educational assessment community and experts felt that there are a lot of shortcomings that characterize the use of this theory in educational assessment, and in terms of error, in terms of the true score and error score, they are uncorrelated. You know, the examining average is 0, and there are so many limitations in terms of sample dependent, in terms of both the item and the test characteristics. So there are a lot of shortcomings that characterize the use of classical test theory, and that led to the development of item response theory, which looks at the probability of an examiner respond to item, at item level, rather than looking at the raw score. So the goal of item response theory is to establish that, what is the probability of examining A getting item 1 correctly? What is the probability of examining B getting item 2? The same examining A, what is the probability of getting item 1, item 2, up to the last item correctly? So it's looking at the Z-score, the standardized score, which is the probability level at each of the items. So, and then by the time you look at this, the item response theory will give you what I call item characteristic curve, and which I'm going to show you when we start the hands-on activities, whereby it will establish a kind of relationship between the underlying ability of the examinee and probability of getting the item correctly. And this is one of the major objectives of developing item response theory. And since the development of item response theory, this has gained a lot of or embrace the usefulness of this particular theory. And though the classical test theory can also, you can't rule it out, because that is the genesis of the theory. There's no way you talk of item response theory and then you will not talk of classical test theory. So the two, they are very important, but it has been advanced in the literature that using item response theory will give you a better result in terms of information and test information to your test items. Therefore, follow me as we sojourn into hands-on activities. So, ladies and gentlemen, I've come to the end of brief overview of how the HAR works, and just to keep you abreast of its mode of operandi and how to import data, and also we talk about the formatting and so on and so forth. Now let's quickly look at a few hands-on activities to show you how the R programming language works, and then to give you some syntax also and see how everything works. Are we together? Can you hear me?
Yes, we can hear you.
Okay, thank you. Now, first and foremost, the first thing you need to do is to create a folder, like I said, when I'm making my presentation. Create that folder, and that folder, inside the folder, that's where all the analysis that you are doing will be saving. So I believe you all know how to create a folder. You can right-click on your desktop, and then when you right-click, you go to New, and then you click on Folder. Name the folder. Let me just name it, let's say IAEA. Let me just name it like this. This is the folder that I want to use. And also, let me open this. I have a data set here. Let me open the data set. Can you see my screen?
Yes, we can.
Okay. You can see this is a spreadsheet, Excel spreadsheet. And I have about 25 items measuring intelligent quotient of basic 5 students. So, and that's why I call it, you see, I name it IQ, intelligent quotient. So there are items developed to measure the intelligent quotient of a basic 5 learners. And at the end of the day, their responses were scored either wrong or right. So for right, we have 1, and for wrong, we have 0. And we have about, I think, about 400 respondents. I think it's about 400 or so, if not. Check. Okay, we have 401. There are 401 of them. Now, this is data set. At times, you have no response, or you have missingness. I don't know. So in R, what R takes, if you have, for example, now, if I have, let's say there is missing data here. So what you would just do for R, just put NA there, not available. Just put not available, NA. It will take it. So you don't leave the that missing cell, and you just leave it like that. So if you run the analysis, the analysis will not run. So you have to put NA, or at times you can put NaN, null. You can also put this, it will accept it. Yeah. And if you are skillful enough, we have different methods of handling missing data. There are different methods that it depends on the kind of missingness that you have, whether it's complete missing, or we have random. There are like 3 or 4 types. And then we have different methods, either expectation maximization, regression method, and so on and so on. There are so many methods you can use to undo the missingness when you have it in your data. And this will ensure data integrity, you understand? And that's why there's a difference between a quack analyst and someone that is an expert in the area of analysis. And I do tell people, the issue of analysis is not everybody's business. It's not everybody's business. Don't say because I can use SPSS, then I'm an analyst. No, it goes beyond that, because there are a lot of things that you look at. The data, the integrity of the data matters a lot. And it will determine the kind of results that you are going to have at the end of the day. If it is properly managed, you have missingness, and then you just, some people will say, oh, when you have missingness, okay, you can use means replacements. Otherwise, you use mean replacement, then you start doing the analysis. Someone that is not there, you understand, and you are using the mean score of other members of the class to say, okay, this is your score. So I don't want to talk. There are shortcomings also using that particular method, but there are scientific method. Yeah, using a Monte Carlo method that will give you appropriate way, or that will handle the missingness well. But if you know that you are not skillful in doing some of these things, just put NA like I said, or NAW, and then that is okay. So this is by data. So what you are going to do now is to format this data. You must format the data to suit the format that the R environment accepts. And then what you are going to do, I told you we have 3 methods that you can use. You can have command delimited, which is CSV. We have the tab delimited, which is TXT, and then we have the space delimited, which is PRL. So these are the three file extensions that our environment, accommodates. So now you come to file. So when you get to file, now go to save as. Now, when you click on save as, you have different directories here. Now, already I've created a folder called IE. This is my folder, and the folder was created on my desktop page. So I click here. So after clicking this, then I want to format, then you come to save as type, and then you will see different file extension that you can use. So I choose command delimited. This is command delimited. If you are comfortable, this tab delimited, you can choose tab delimited, and then this is space delimited. So you can choose any of these three to format your data. So, but for me, I prefer using command delimited. So you click on command delimited. Now, another thing that when you get to file name, make sure your file name is as short as possible. Though the rule says it must not exceed 8 characters. 8 characters. But I prefer using a very short word to connote the name of the data. So let me continue using IQ, or let me use, let me just say, okay, let's leave it as IQ. So now I want to save the formatted data now inside the folder I created earlier on my desktop. So you click on OK. So when you click on OK, it will pop up a box, and then it will say some features in your workbook might be lost if you save it as CSV command delimited. Do you want to keep using that format? Then you say yes. Click on yes. So after doing that, then you can close the data set. Now go to the folder you created. This is the folder IAEA, then open the folder. So when you open the folder, this is the formatted data. And when you look at the type now, you will see Microsoft Excel, comma separated file. So this one is telling that this has been formatted as command delimited. This is the first order that you need to, or step that you need to perform while using your our programming language. So if you have successfully installed the software sent to you, you're going to have something like this. Is the symbol. You can see the symbol. I have the version of 4.02. Yeah, so and then my operating system, we have, I'm using 64 bits. So you have this logo showing that it has installed successfully. You understand? So, and you are going to have two. We have the R and we have the R Studio. I sent the two software, R and the R Studio. So I prefer using, you can use either of the two, either R or R Studio, but I prefer using R Studio because it's more interactive compared to R alone. However, the R Studio cannot work on its own without having R installed on your system. So automatically, the two needs to be installed on your system. So if you have installed this successfully and the R, so let me go ahead then and open my R. Okay, this is my R Studio here. It's coming. Can you see it? This is my studio. Can you all see it? Hello?
Yes, we can see it.
Okay, fine. So this is my house studio. And then when you open your house studio, you have about 4 different what is it called, stage there. This place is where you have your syntax. This is the global environment where you have the history. And then this place is where you have the plot. If you have any plot, this is where it's going to display the result of your plot. And then this place is where if you run a particular code here, if it is successful, this is where you will know whether the code is correct or not. So we have this. So this is how the environment looks like. This is how the environment looks like. But this is R Studio. But if it is normal R, let me open that normal R for you also to see the difference between the two. Yes, this is normal R. This is normal R. So, and there is the same thing, it's the same work, it's the same function that the two of them perform, but I prefer the other one to this. So you can use this also. It's the same code lines that you use on R Studio. It's the same code lines that you are going to use on R also. So the two are the same. So let me go back and where's my R Studio? This is my R Studio. Now let me tell you how to install a package. How do we install a package? And like I said, for every analysis, there must be a package. There must be a function that's suitable or appropriate for that analysis. Though there are some little things that doesn't require a package, like the x1 equals to 2 plus 5 that I cited the other time. It doesn't require any package. It's just a simple arithmetic that you can just type and then to give you answer. You understand? So now, for you to install a package, this night we want to do classical test theory, item analysis, and then item response theory, item analysis. And for the two of them, for classical test theory, the package that we are going to use is called Psychometric. That is the name of the package, Psychometric. Psychometric. The name of the package is Psychometric. Psychometric. That is the name of the package, Psychometric. And we have for item response theory, we are going to use latent traits model package. And the acronym is LTM, latent trait model package. For item response theory, that when Dr. Ario contacted me that I should make presentation this, I told him that it's a very broad area. So it's a very broad area. But one thing is, tonight I just want to expose you to basics of using this, so you can go and amplify on it. There are so many packages that you can use to do item analysis, to do equating, to do differential item functioning, differential bundle functioning, to do so many things. Even the structural equation model, you can use how to do some of these things, and then you have a fantastic result compared to other software, and you see that there is a kind of difference between the two. So these are the two packages that we are going to use tonight, and I'm going to show you how to install this package on your R environment. So this is the tool. You come to this place, you have the tools. Can you all see it? You have the tools. I'm going to show you how to install here using R Studio, and then if you want to use the normal R, I'm going to show you how to install the package. So when you click here, you will see install packages. Check for package update, function control shell, terminals, and all that. So we are interested in the, like I told you that at times, if you download and install a package today now, maybe in the next 2, 3, 4 weeks, probably there's an update on that package. You understand? This is where you will check, and then you will just click on the package and it will update automatically. What you need is just a very good internet to do the downloading, the updating, and even to download that package. So once the package is downloaded and installed, it is there forever, except if you want to update it. So you don't need any internet again. You understand? You only need internet at first time that you want to download it. So when you click on install package, you wait a bit. So immediately you click on install package. I told you that the repository used by R is called CRAN. So all the packages, over 10,000 packages, are being built inside or domicile inside the CRAN, which is Comprehensive R Archive Network. And this is the repository. So any package that you want to install, you download, then you find it inside the CRAN here. Now, so what you are going to do, you have the packages, separate multiple with space or comma. So the package you want to download, just type the name here. For example, now Psychometric now. I'll just type Psychometric. Psychometric. Okay. So can you see we have different site? In fact, the moment you type that site something, it will bring different options for you. So this is the one you need. So you look at it and then you click on the psychometrics, and then after that you just click on it. I'm coming. So, but because I have it already on I have it already. So once you click on it, the moment you click on it this, then you click on install. So once you click on install, it will start installing straight away. And then you make sure that this one is checked, install dependency. This must be, what is it called? This must be checked. So once you do that, the package will automatically installed on your system. So this is this. Now let me show you if you are using the normal how. So what you will do, you just come to package, you see the packages. You click on package, then you see set CRAN mirror. You understand? And then you see load package. So you can first of all, I'm coming, you click on load package. So we have different, all these, they are different packages. I told you we have, there are so many of them here. There are so many of them. So you come here, then you select set the CRAN mirror. So you choose a location, like I told you when I was making my presentation. So we have the Australia, we have Belgium, you have everything. So I prefer taking, you go look for UK. So I take UK, Bristol. Can you all see it? So you click on it. When you click on it, just click on OK and wait. But meanwhile, you must have a very good network. You must have a very good network. If the network is not good, it will be very, very slow. I'm expecting something to come. I'm expecting something to pop up. Okay, let me take, because I'm in South Africa, so I have the South Africa here. So let me take this. And let's see. Why is it not coming out? Okay. Sorry. I think okay. So this is what you are looking for. So you click here. So when you click here now, this is the package you are looking for. So after clicking there, click on OK. You start installing. Can you see it? So when it installed successfully, you will see all this. You see successful unpack, blah, 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 blah. You understand? So, but if it is not successful, you will see some error. It will give error, and that error will come in, what is it called? In red. You see the download binary packages are in this user, blah, 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 blah. So mean that it has installed successfully. Let me close this. Okay, well, let's just leave it as it is. Like I told you, I prefer using the R Studio. Yeah. So after you install that, and another one, you install the latent trait model also, which is LTM. Just write this LTM. This is it. You click on it. Then after clicking on it, make sure you check the install dependence, and then you click on install. It will install automatically. And then you wait until the installation finishes. So that is how to install. Now, let's go to the main business. And now we want to import our data set into the R environment. How do we install, how do we import the data? And like I told you, this is not as easy as other software that you just, once you have them on the spreadsheet, then you can start using them. For her, it's different. So what you are going to do, you have to start you write a code lines to do this. Are we together? Hello?
Yes, we are with you.
Okay, okay. So what you are going to do now is just write get WD. This get WD means get work directories. Get work directories. If you remember when during my presentation, I told you the steps to follow when you want to import data, your formatted data into the R environment. So the first code line that you are going to write is get work directory. We want to see the current working directory. So you have the get and the get WD, then open and close brackets like this. You do see it. So after that, you come to this place, you see run. So we want to run this code, whether the code is right or wrong. If the code is correct, you understand, it will turn to blue. If it's not correct, you will see error. So as it is now, you come here, once you write it, you put your cursor in front, and then you now click run. You click on run. So when you click on run, this is where you see, you come down here now and see whether the code is right or wrong. But you can see now that it says get WD, you have C / users del document. You understand? And like I told you, this command line, you can see the greater that I showed you the other time. So if you run the code and the code was successful, then it will give you this. You will see the greater, telling you that continue with the next line of code that you want to write. But if it is wrong, let me, for example, let me write get, let's say I just say GG ET, then open bracket, close. And I try to run this now. I said run. Can you see? It said error in this, could not find the function. So meaning that this code was not run successfully, so that there is a problem. So you need to revisit the code line. So let me clean this. Let me rerun this again. So can you see now, when I run it, you have this. So the next thing you are going to do, we know that the get working directory is telling you that fine, you are using Dell. You understand? The user that this desktop is Dell. You understand? And then you have documents. Now I can now say, let me set the work directory. You said set WD, that you want to set the work directory, open close bracket, open and close bracket. Then you come to this place, just copy this as it is. You know, I told you one of the strengths of R is that it is very flexible. You can copy, you can paste, you can copy something, then you edit, you know. So, and that's why it is flexible. So let you copy this, you highlight, then press Ctrl+C. Then come to this, put the cursor inside the open and close bracket, and then you paste it by pressing Ctrl+V on your keyboard. When you press Ctrl+V, you have this. Now, we want to change. That's why I said set work directory. Initially, we said get work directory, that we want our initial work directory is this. Now, set work directory means we want to set our work directory to suit where our data, our formatted data was put in, or where we created our folder, and then we put the formatted data is. So you know that our formatted data, we created the folder on the desktop the other time. So, and this is document. This directory now is document. So you just place a cursor there, then change it to desktop. It just says desktop. Desktop. Now, on the desktop now, this is where the desktop directory, that is where we created a folder for this analysis. So you now say slash, what is the name of the folder? The name of the folder is IAEA. Meanwhile, if I use uppercase to name that folder as IEA, then here also you must use that uppercase. And that's why I told you that R is case sensitive. If you use IEA as uppercase, and when you get to this place and you put lowercase, the syntax will not run, the code line will not run successfully. So after this now, just put your cursor aside and then come to run, and let's see whether it's going to run or not. So can you see now? You will see the greater telling you that continue, this has run successfully. So the next thing now is to read our data. We want to read the data that we save, the formatted data that we save inside this folder. Now, the name, let's just name it, it said IQ data. Then you put this less than, then you put Ivan in front. Then you can say read dot table, because we want to read the table. I want to read the data rather. Read the table, open, close, open and close a bracket. Then inside it, then you have the two apostrophes. Now, inside the two apostrophes, now, this is where you now put the name of the formatted data, which is IQ. If you don't forget, we use capital letter, which is IQ. Now, the file extension is CSV. If it is tab delimited that you use, you put it. If it is space delimited you use, you put it. But in this demonstration, I formatted the data using CSV file extension. So you now say IQ.CSV. Now, place the cursor, move the cursor outside from this the two apostrophe, then put comma. After the comma, now write sep. Sep means that you want to separate the column. So open another two apostrophe. In between the two apostrophe, put a comma. Now, move your cursor from there. You now put another comma. Now, you now look at your data set. Do you have variables on this data or not? Do you have the variable? Did you name them? And if you remember, we have Q1, Q2, Q3, telling you that data set, we name it. We have the variable name. But if you don't have the variable names, there's a way you can do it also. So what you will do, you just write header. Just say header. Now, because we have variable view, then variable name rather, so you put true. But if you don't have it, you put false. You put false at this point. But because we have it, then we put true. So place your cursor outside. And then after that, run it and let's see. So you see that it ran successfully now. So automatically we've imported the data set. Now let's see whether the data has been installed successfully or not. So to check, just write their names. Let's check the variable names, open and close brackets. Now, okay, before this, you know, I said something when I was doing my presentation. I talked about assignment, expression, and printing. So when you have an assignment or expression, then you must print also. Now, this is an expression, this is an assignment, you understand? But this code line has been assigned to IQ. So whenever I want to make reference to the data set now, I'm going to write IQ. So I'm using IQ to print the assignment or the expression that I just wrote here. So here now we have just say names, just to check whether the items have been imported or not. So we have names, open and close bracket, and inside it you put IQ. Then click on run. So when you click on run, you will see it. It's like Q1, Q2, Q3, Q4, up to Q25. This is to tell you that already the data has been installed, import successfully into the R environment, because these are the variable names. And if so desire that, okay, you want to see the data, then you can say fix, you can write fix, open and close brackets, and then you put IQ. And then let's run it and see. Can you see it? So the data set has been installed successfully. So we have,
you can see it.
Yes. So we have, this is 25 items, and these are the responses. And when you go down, you will see that we have 400 and what? But okay, 400 examinees. Is that taken? So this is to confirm that, okay, the data has been installed successfully. So let's close it. Now, having done that, the next thing, now already we've imported the data successfully now. So the next thing now is to perform the main analysis that you want to do. And we are using the classical test theory and item response theory. So that package that you download and installed earlier on the R environment, this is where you will need that package. So you need to call the package. So for example, now, if I write this and I said, call the package. This one now, because of hash, this one is just telling you that the next syntax or the next code line is to call a particular package. So it's not a code line. So whenever you see this hash, you understand, in any code line, just know that it's not a code, but it's something that is describing the next code, that, okay, this is what this code is talking about. Because at times you will see people, they will just write a lot of code lines and then you'll be wondering that, oh, what is the essence of this code? So if you want people to know that, okay, this particular code is meant for XYZ, then you can write something like this and you put the hash. So now there is what you call library. So immediately you download and you install that package, it goes straight to the library, your library. There is a library inside the R environment. So you just write library. Can you see it? Library, or say library. So what is the name of the package that you want to use? So you just write the name of the package, Psychometric. This is the name of the package. Then place the cursor outside. So when you place the cursor outside, then you click on run. When you click on run, when you are calling this package for the very first time, it's going to give you all this. And it will tell you that it loads under blah, 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 and then it was built under a particular fashion and all that. And you see that at the end of the day, the greater is there. And this greater is telling you that continue, that the previous code line is okay. But if it is not, you will see error, or if what is it called it? This line is not completed, the code line is not completed, and you press run, you will see plus. So after calling for this particular package, which is psychometric, and this psychometric is used to establish or the psychometric properties of a multiple choice item. And that's for classical test theory. So after that, the next thing is to write another code for, and then for classical test theory, you talk of difficulty of the item, you talk of discrimination. And you know that for difficulty, it's just the proportion of those that got the items correctly. So let's write the code for this one. So let's say CTT, then let's use underscore, or let me say, okay, let's do P. The P represents the difficulty, that is the symbol. Then you have this like this. Then you have item dot exam. Then you open bracket like this. Then what is the name of the data? The data you imported is what is IQ. And make sure, because the IQ is capital, is uppercase, don't use lowercase. If you use lowercase now, it will not run because you are not consistent. And that's why I said the R is case sensitive. So after that, just put comma. Then you said Y equals null. That is the syntax you are going to use. Equals null, comma, and then you can say this tree. Then, because you want to estimate the difficulty, then for discrimination now, it will be false. You said false. False. Then bring your cursor outside. Then click on run. You will see that the code ran successfully. You understand? Because you see the greater, meaning that continue. So the next thing, like I told you, this is an expression. This is an assignment. Now let's print using this now. So you now say print, open and close bracket, CTT, so it bring it underscore P. So you have this, and then you click on run. When you click on run, you have your results. So this is the, I'm coming. This is the results for difficulty, the classical test theory difficulty. And when you look at this now, you see the difficulty. Then when you come to discrimination, you see not available, because we are only interested in running difficulty alone, the difficulty index. And you see that you can't compare the results, the robustness of the results or outputs that you are going to have in R. You can't compare it with any other software. Now this one, it gives you the sample standard deviation, the item total WI, we have the item criteria, and then we have item reliability. And this is very important. That is the reliability for each of the items, even before looking at the entire reliability. And you know that for classical test theory, is interested in reliability of the entire test, because it's looking at the test level, the raw scores. So when you look at this one now, we have 0.4 for item 1 now, the difficulty we have 0.8975. And this one is telling you that about 89% of the examinee got this item correctly. And this is pointing to the fact that this item is very cheap. 89% of them. Now this one, item 2, now we have 0.9050. This is about 91% or 90%, telling you that this item is also very cheap. Now, going to the next one, we have 0.76. This is about 76%, telling you that this, and you know, for difficulty, it has been established in the literature that if you have from 0.2 to 0.8, that is the range. Some school of thought says 0.3 to 0.8, some say 0.2 to 0.6. But it's a matter of what you want to achieve with that test. Which age group, you have to look at that also. So there are a lot of things. So judging the criteria for the good item or the level of difficulty of the item is not judgmental. It's not something you say, okay, it's from this to this. Something must have dictated that choice of that range. So you have to look at the age group you are targeting, and then based on that, you say, okay, let the level of difficulty be this. If it's an aptitude test, then, and you want to prune, scrutinize the number of applicants, you want to reduce them drastically, then you have to, make the level of difficulty to be more stringent. Now, let's save this now. How to save your output in R, how to save it. So to save it, there are two ways. Now, the first way is to say you write a syntax, you said sync, open and close bracket, then you run it. Okay. They said something, can you say warning message in sync, no sync to remove. Okay. Let's continue and let's see. We have sync, I'm coming, sync, open and close brackets, and then this one now, the print, this one that you print. So have the two apostrophe and then you say CTT underscore P dot test, and then you run it. So it runs successfully. And after that, you now say CTT underscore P, enter. Now, to unlock it, because the moment you start, we started with sync, meaning that, okay, we want to save this output. Now we save the output. Now, after that, we have to unlock it also in order to continue with our analysis. So you write sync again, sync, and then you run it. Now, before we continue, let's go and check the folder whether the output has been saved there or not. Can you see? It has been saved. But it said 0 kilobytes. Now something is fundamentally wrong. Okay, maybe it's still working. So, but it has saved, we have it there. Now, you can also, the second way by which you can do this, you can copy. There is a way you can copy. Just go. So you can do the normal copy and then just right click and then you let me just show you. Let's say you want to copy now. Then you right click on it, copy. Then you can open a notepad, and paste it. And then you save it, and then you can import it into your Microsoft Word and all that. Oh, sorry, I think I mistakenly stopped sharing. So that's all. Now, and that's for difficulty. Now let's do for discrimination, or probably if you are interested in having the two, both the discrimination and difficulty at the same time. So what you will do also is to say CTT now, but this time around, let me just put a there, underscore this. Then we have item.exam, psychometric, and then we have the IQ, which is the name of the data set, y equals to null, then underscore this three, and then put true there, true. then you can go and run it. You run. So it runs successfully. So to print now, you said print, open and close bracket, you have CTT. So pick this, and then you click on run. That's run. So when you come here now, you will see that you have both the difficulty and the discrimination. Both the difficulty and the discrimination. And another beauty of this, if you use BiLogMG for a classical test theory calibration, you are going to have the phase 1, phase 2, and phase 3 thereabout. For your difficulty, you still have to divide it by 100 before you can say, okay, this is the right difficulty, because it's going to give you the omnibus score. But here, you don't need all this. The computer, the software has calculated everything just for you to extract the. So when you look at this one, this is 0.8975, and the discrimination is 0.26. And you know that the benchmark for discrimination, they said for a good discrimination, it must be greater than 0.2. You understand? So when you have greater than 0.2, you have the better information provided by the item. So for you to choose that, okay, if you are using classical test theory, which is test development, you are just developing a new item, and you want to use classical test tutorial approach to determine the items that's good, you understand, and to see which of these items are poor for you to expunge or to revise. Then it depends on the range you choose. If you say, okay, your discrimination must be 0.20 less than or equals to D must be greater than or less than or equals to 0.20. You understand? So, and then you have this. So, and therefore difficulty probably maybe from 0.2 to 0.8 or 0.3 to 0.8. So you will see that you can conclude that this one is good. You understand that you have a 0.89 to 0.26. You can go for this item. This item is okay. You move ahead like that, like that, like that, like that. And you can see most of the discrimination here is okay. We have 0.26, 0.19, 0.3, 0.42 down. Yes, I think most of them are okay, except for this, which is 0.06, which is too bad. 0.08 also is too bad. And also when you look at the Q21 item 21 and item 22 also, you will see this is 0.18, meaning that just 18% of the examining got this item correctly. So the implication is that this item is very difficult. And aside for the difficulty, you see that the item fails to even discriminate between those, the higher ability student and the lower ability student. So that is the implication of this. And you can see that these two items are poor, you understand, considering probably the age group of the examining. So ladies and gentlemen, this is where I'm going to stop. I told you that if you continue till tomorrow morning, we continue working. It's a very broad area, and we can't finish it in just a single lecture. But this is the classical test theory way of using R programming language to establish the psychometric properties of this instrument. Thank you, and God bless you. And if you have any question, I will be glad to respond. Thank you, and God bless you.
All right, thank you very much, sir. We appreciate the time you've taken so far to being with us. And I must say the teaching tonight, at least even though it was an introduction, it was thorough. So please, due to time, maybe we'll only entertain about 1 or 2 questions so that you can bring the meeting to a close as soon as possible. So please, if you have any question, you could kindly use a raise of hand, and I will ask you to unmute so that you can ask your question. All right. I will start with Mark. I hope I got that right. So please kindly unmute yourself.
Okay, thank you very much for the opportunity. I hope my microphone is clear.
Yes, yes.
Okay. I had a little issue with my installation, and so I couldn't follow. I don't know if the video will be sent to us right after the meeting ends. Hello.
Oh, yes. I got that.
Okay, and number two, I don't know whether the data doc was using for the illustration was sent to us or something.
Okay, I will send the data.
Oh, okay.
I will send it to
Thank
the
you.
organizer.
Okay, thank you.
All right. I hope you got that. So the next question, sorry, I don't know the gender. Kayagma Bala, I will kindly unmute and go right on to ask a question. Please, if your question has been answered, you can lower your hand. Thank you. All right, go right on.
Hello.
We can hear you, sir.
Okay. I wanted to find out about the IRT, but before that, I want to thank Dr. Musa for this wonderful class, the wonderful presentation. I actually enjoyed it, though my network was fluctuating too. But I want to find out, are we going to have another class for the IRT, that's the item response theory, or we can actually imply from this particular one, from the classical test theory?
Okay.
And
yes.
then secondly,
Okay.
I want to also request if we could also have the video recording of this class, because it's very important to us. Thank you very much, Doctor.
Yeah, thank you very much. Like I said, that the area is very broad, so it's not something that you can finish in a single section. So I believe the organizer will find a better time also to continue with this section and to talk about the item response theory, because that is where the bulk of the work is. Classical test theory is very straightforward, and you know that in terms of the measurement theory, the limitations are there and so on and so forth. But where we have a bulk of work to do is under the item response theory, because of the stringent assumptions and the mathematical approach that you need to fulfill before you can do the analysis. But I think the organizer will find a better time for us to look at this. Thank you.
All right, thank you very much. Yes, there will be another class, another section for that. The next person, Kennedy Akudo. Kindly unmute yourself.
All right, thank you for the opportunity, and special greetings to the presenter for the nice presentation. I have two questions. One is with respect to the results, the output that we were advised to use a second method, that is to copy and paste on a notepad and thereafter transfer to Word. During the process of transferring to Word, will it not scatter or will it remain the same? That's my first question. My second question, can I have a syntax for sketching of normal distribution curve using R console? Those are my two questions.
Okay. Let me start from the last question. Like I said, that the R software is a very powerful software, though it's sophisticated, and I believe that anyone can learn and know how to use the software. And there is no analysis, there is nothing, I'm saying it authoritatively. There is no analysis that you cannot run on this software. So saying normality assumption or homogeneity assumption, any of the assumptions that you want to establish, it is capable of doing so. But you know, the problem, like I told you, I'm not a computer scientist, I'm not a programmer. So some of these syntax, even before you use it and then it runs successfully, it takes a lot of time. You have to sit, start writing these codes, and you understand, consulting, read, and you know, and so on and so forth, before you are able to say, okay, oh, this code works perfectly for what I'm interested in. But believe me sincerely, there is nothing this R software cannot work on. And the second question on the issue of copy and paste, that one is another training on its own. When you have an output on Notepad and then you want to import the output into your write-up, that is the MS Word. Definitely, if you import it as it is, it's going to scatter like you raised. But there is a way we do the formatting, and even if you use other software also, I think most of the output comes out in either text delimited or CSV, and then you still have to do a kind of data formatting before you can. So I think if time permits us, I will still put you through on how to do this. Thank you.
Thank you very much, sir. I do hope the questionnaire got the response. All right, I think I have 3 people now with their hands raised, and after these 3 people, no other question will be entertained. So please, Stephen, Biden, you can go on with your question. Kindly unmute yourself and go on with your question.
Okay, thanks very much for this session. And I want to thank Dr. Musa for this intro to item response and CTT. I was hoping that maybe in the next session, if the data for the session could be sent to us prior to the session, this will help us follow through. Because I had R installed on my computer, hoping I could follow with the practical session. But because the data wasn't available, I couldn't do that. So I'm hoping in the next session, maybe the data could be sent to us prior to that, before we start with the session.
Okay, sir. Thank you.
Thank you. And I'm hoping, like he did mention, that he will send the data to us.
Yes, I will.
We can, okay.
I think they should do the needful.
Thank you very much, Doc.
Yes, you're welcome.
All right, thank you very much. Chinazom Uranger, sorry for not pronouncing that very well. You can unmute yourself and ask your question. Thank you.
Hello, thank you very much. Can you hear me?
Yes, we can. You're welcome.
Okay, thank you very much for the lecture. It was very educative. Please, I tried following the lecture during the course and the practical, but I kind of downloaded the R and not the R Studio. Now, I want to know if the same command can be used on the R. The same command he used on the R Studio, if it can still be used on the R, because I got lost by the wayside. I couldn't download the R Studio. I just used the other app. So I want him to clear me on that. If I follow the same command, I will still arrive at the same working and offer the analysis, or he can teach with the R maybe next time for those that couldn't download the R Studio. Thank you.
Thank you very much. I think I sent the two to the organizer, both the Haro and the Haro Studio. But in terms of syntax, it can work in any of these, either the R Studio or R. So far, you have the package downloaded and installed on your R environment. Thank you.
I do hope you got that, man. All right. Adebanji John, you can unmute and ask your question.
Good evening, sir. I want to first of all thank the doctor for the wonderful presentation today. So my question is that I don't know if we can code directly in now instead of formatting it. I mean, coding in Excel or SPSS before formatting it importing it into the R. Is it possible to code directly in now? That is my question.
Is it possible to what? To code directly?
Directly in R, in our software.
That's what we did.
Instead of you import the data from the Excel and maybe SPSS and import it into R, format it into R before using it. Can we do that as we normally do in SPSS and Excel?
No. You see,
okay, sir.
Each of these software, if you are familiar with some of these softwares, you understand, you must format the data, you understand, before you import it into any of, even if you are using M+, also use CSV tab delimited. If you use BylogMD use fixed ASCII format. So if your data is not in this file extension, it will run. They won't take it.
Sir.
If you are using DIMPAC for dimensionality test, it has to be in fixed ASCII format. So each of these software, they have their way of, what is it called? Their way of formatting them. And I also said in the course of my presentation that you can have your data set on SPSS or Excel without even formatting either to CSV or test tab delimited or what have you. But before R can take that data set from either Excel or SPSS straight away, you need another package, and the package is called Heaven. That is the package. So you have to download that package. If you download that package, there is no need of doing any formatting or anything. It will take, the R will take it straight away the moment you call that package when you want to import data from the SPSS. Thank you.
Thank you, sir.
All right, thank you very much, sir. Well, a lot of questions on the chat, and they will be responded to. And you could also ask your questions via email. You will send your questions to info@iea.com, and we'll get that across to the speaker, and we'll get your answer back to you. So thank you very much for everyone who has participated in tonight's demonstration, so to say. Our programming language, it's applicable to everyone in every field. I've seen people in the medical line, saying, oh, come on, I want to learn our programming language. It's used for data analytics, for people in medical, people in engineering, and people in all spheres of life. So keep your hands on it, keep practicing. That is the only way. Keep practicing and keep doing that, and enjoy the best that our programming language has to offer you. So we want to appreciate our speaker tonight for taking us through the R programming language. It was indeed an insightful section, and we didn't know that at some other time we invite you, you expand more of these things to us. So thank you on behalf of IA IIEA and as anchor for tonight. Thank you for joining us.
Thank you very much.
You're welcome, sir. And just an announcement before we call it a day. The 5th conference of the association is built for November, and that's Monday 7th to Friday 11th. And this is a call for papers to be presented during the conference. And the theme for this year is development-driven educational assessments for transformation and survival, with the following sub-themes. Number 1, educational research, development, and publishing strategy. Sorry, please just give me a minute so I could share my screen and you could follow along. Okay. All right, I do hope you can see my screen now. We have enhancing assessment policies to reflect changing national and international curriculum. We have entrepreneurship education and employability. Number 4, examination security breach, formative and summative assessments. Number 5, cybersecurity and educational assessment. For me, I'm so very much interested in this number 5, cybersecurity and educational assessment. And the 6th there is globalization education for national and international cohesion. Number 7 there, inclusive educational assessment for learners with physical challenges. And we have innovative and consolidating alternative methods of education assessment in post-COVID era. And number 9, intercultural communications and education assessments. We have investigations in sciences, technology, and humanities-related disciplines, issues of validity and reliability in educational research, and also lifelong learning for self and national development. And we have machine learning, e-learning, e-assessments, and digital laboratories method. And then finally, we have medical research and assessments. And we also have nurturing innovations, creativity, and technology for sustainability. And we have school ridership, management, and educational policies, challenges, and solutions. And then lastly, we have university, industry, government partnership for transformation. And also the following workshops, topics are also available: application of test theories in educational assessments, development of an electronic test item banking system, introduction to big and artificial intelligence in education, introduction to computer adaptive testing and multimedia test items. And we have modern approach to educational guidance and counseling. We have new trends in research methodologies. And we have plagiarism detection in technologies, intellectual property rights, and policies. And we have secondary school education beyond the traditional classrooms. If you need further information, you could send an email to info@iaia.org or iainternational@gmail.com. And the fees for this year conference for physical participation, both national and international delegates, is $200, while late registration is $250. And for virtual participants, for the national and international delegates, it's $100, while late registration is $150. And for the student delegates, $50 for early registration and $75 for registration. And the conference stop fee is just $50. So please, if you need further details, you would contact the secretariat at info@iaia.org. Thank you very much for spending your time with us here tonight. I do hope we've gained a lot. At this time now, we're having the closing prayer, and please, I will request Patience Langu to please give us the closing prayer. Thank you. Please kindly unmute yourself. Okay. If you are not getting any response from her, please can see some session. I'm sorry for murdering that name. Sincere apologies, please. Please, can you unmute yourself and give us the closing prayer?
Pray. Eternal Rock of Ages, we thank you for this moment, especially for giving us the grace to attend this webinar and for the grace you have given to Dr. Musa Adekunle Ayonwale to be able to do justice to the issue of classical test theory while we are waiting for the continuation into the item response theory. We thank you for all participants, and we give you glory for what we have been able to achieve. We thank you for the organizers too, and we pray they will be able to do more. This webinar is closing, and we'll be going to put our body to rest. Grant us a good rest for today and bring us safely to the other day tomorrow to your glory. For we pray in Jesus' mighty name. Amen.
Amen. Thank you very much.
Amen.
For everyone who has thank you very much. Sorry for the obstruction. Thank you very much for everyone who has participated in tonight's presentation. Do have a lovely night's rest here from Nigeria. Here in Nigeria, it's already 10:26 p.m. and it's bedtime already. So thank you very much for everyone. Do have a lovely night's rest. And please, as I've said earlier, if you have any question, I could see someone raising his hand. We are sorry the meeting has come to an end, but please send your questions to info@iia.org, and we'll be pleased to respond to your question. Thank you very much.